Two datasets of 23 integers each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10 but less than 20. The second interval represents the frequency of integers greater than or equal to 20 but less than 30, and so on. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? So the goal of this question is to minimize the difference of the mean of dataset A and the mean of dataset B. So let's try to understand this particular line, the underlined section. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10, but less than 20. If you look at the first interval, it can contain values from 10 all the way up to 19, as illustrated by this particular line. Since the frequency of this interval is 3, it can contain only 3 values. Now, what are those 3 values going to be? They could all be 10, they could all be 19, or they could be any integer combination between 10 and 19. For example, 11, 13, 19, or for instance, 10, 11, 15, any combination. The histogram does not show what exactly the values are going to be. But because the goal of the question is to minimize the difference between mean of dataset A and the mean of dataset B, as shown in this particular line, we need to find a clever way to minimize the difference. Now, how do we go about it? To do this, we take the lower bound of dataset A. For each of the intervals in this histogram, we take the smaller value, i.e. 20, 30, 40, and 50. For dataset B, we're going to take the upper bound, which is going to be 19, 29, 39, and 49. Now we're going to calculate the mean for both of these datasets respectively. For dataset A, the mean is going to be 20 times 3, because the frequency is 3, plus 30 times 4, plus 40 times 7, plus 50 times all over 23. For dataset B, the mean is going to be 19 times 3, plus 29 times 4, plus 39 times 7, plus 49 times 9, divided by 23. And we're going to subtract the two means, mean of dataset A minus mean of B, and the answer is going to be 1. So 1 is the answer. Let's look at a shortcut to solve this question. Dataset A and dataset B have the same histogram intervals, but dataset A has been shifted 10 units ahead compared to dataset B. So since both of these histograms are equivalent, since both of these histograms are identical in shape, we can ignore all of this part. We only need to look at one of the intervals in the histogram. And since we're calculating the difference, we don't really need to calculate the mean. We only need to see the difference between one of the intervals. So we're going to take the lower bound of this interval, the larger interval, which is going to be 20, and the upper bound for the smaller interval, which is dataset B, which is going to be 19. And 20 minus 19 turns out to be 1. So that's another way to solve this question.